ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Today I am here to explain one of the application of ordinary differential equation. While solving or while studying ordinary differential equation, we always have a question like why we should solve this equation? What's the use of it? Is really applicable in our real life? Why initial conditions are given? How they got? Those are the questions will arrive in our mind. In this video, I try to give answer to those questions by taking an real world problem. Let us consider an situation in which someone found a dead body in a room and called the police for the investigation. Police came to the room, and as soon as he entered the room, he measured the body temperature of the dead, and it was found to be 90 Fahrenheit. And at the time was 12 a.m. After 1.5 hours of investigation of the room in search of some evidence, he comes to know that the room temperature was 82 Fahrenheit. And again, he measured the dead body temperature, and he noticed that the body temperature was dropped to 87 Fahrenheit. Now the question is, what is the death time of the person? This is a real world problem. Now we need to find at what time the person was killed or died. For this, let us collect the information or data regarding this real world problem. Firstly, when police entered the room at 12 a.m., the temperature of the dead body was 90 Fahrenheit. So let us take T of 0. Here capital letter T represents the temperature. Here for my convenience, I considering the 12 a.m. as 0. I think next will be you understand why I have taken 12 a.m. as 0. So let us take it as T of 0 is equal to 90. Next, after investigation of 1.5 hours, the dead body temperature dropped to 87 Fahrenheit. So in this condition, let us take T of 1.5 is equal to 87. So clearly you have observed here T of 0 means T of 12. T of 1.5 is nothing but T of 1.5 hour, which means 1:30 a.m. For this, I have considered AM as 0, sorry, 12 as 0 and 1:30 as 1.5. Next, the room temperature was found to be 82 Fahrenheit, and let us take it as the surrounding temperature. Let the denote as Ts, which is equal to 82. Here we comes the initial conditions, which means T of 1.5 is equal to 87 and T of 0 is equal to 90. So second question is already answered. This is how the initial condition for the differential equation are generated. It is all not simply given, it has some meaning. In this collection of data, you come to know that how initial conditions are formed. Next, for solving the uh, problem, we need to know one of the law which is known as Newton law of cooling, which states the rate of change of loss of heat from a body is directly proportional to difference in the temperature of the body and its surrounding, which in the form of dt by dt is equal to k of Tt minus Ts. Here, capital letter T represents the temperature and small letter t represents the time. In this, T suffix T is equal to temperature of the body at the time T, and Ts represents the temperature of the surrounding, and K represents the constant. Now we substitute the collection of data in this differential equation. You are clearly observing the equation. It is a clearly first order linear differential equation. Here dependent variable is t and independent variable is capital letter T. So observing this equation, let form a differential equation, which means collecting the information. Here Ts is equal to, and which means the surrounding temperature is 82 and T of 0 is equal to 90 and T of 1.5 is equal to 87. So clearly it is a simple ordinary differential equation. We can be solved by um, variable separable method. I am not going to solve those questions. Directly I left to you. Once we solve the differential equation, we get T of t is equal to 82 plus 8 into e power 0.3133 into t. Now we know that the normal body temperature of a human being is 98.6 Fahrenheit. So substitute these values in the above resultant equation. T of t is equal to 98.6, which means the normal temperature of the body, normal temperature of a human being. On solving this equation, we get t is equal to minus 2.33. So here the time is given, which is negative. So t is equal to minus 2.33, which means in the initial condition, or in the initial collection of the data, we have considered 12 a.m. as 0 and 1:30 a.m. as 1.5. So using same logic for this value, we are going to get the dead time is around 9:30 a.m. Sorry, 9:30 at the night, which means we need to consider 2.5 hours backwards from 12 a.m. So clearly the times we have calculated, the dead time of the person is 9:30 a.m. This is the one of the basic and most interesting application of ordinary differential equation. Just this is a first order differential equation. So clearly it helps in the investigation of a murder case, or similarly by using this application we can calculate the body temperature of two substance. Likewise, you can calculate many some temperature like such problems. So I think in this video you have learnt one of the application and how initial conditions are formed, and how using those conditions how we have solved the first order differential equation. So I think hope you all enjoyed the video, and thank you. Stay safe.